Alright, so here we're going to use it. We're going to look at using the calculator to find theta and to evaluate trig function. So hopefully you have a graphing calculator with you. Alright, so when we are evaluating trig functions at an angle, we looked at this in the previous section when they were angles that we could draw a nice triangle for. So for example, a 30-60-90 triangle or a 45-45-90 triangle. If we have one of those angles, then we can draw a triangle and we can evaluate the trig function without a calculator. Or we can use the unit circle, which we'll look at later as well. If we don't have one of those nice angles though, then it really just comes down to using the calculator. So how do we use the calculator for this? Well, if I want to evaluate the sine of 23 degrees, I'm going to go to my calculator, and here we have to pay attention to the mode that we're in. Since I'm going to input degrees into the calculator, I need my calculator to be into degree mode. So I'm going to go to mode, and here I have normal, float, and then I have radian or degrees. Degrees is highlighted on mine, so I'm going to stick with that. Had it not been highlighted, I would arrow down here, go over to degree, and hit enter. Now I quit, and I type sine 23. Hit enter. So the sine of 23 degrees is 0.391. We are always going to round to 3 decimal places unless you are otherwise specified or told to, or obviously if you're dealing in terms of dollars. Next one, we want to evaluate the cotangent of 2. Okay, well, if we look at our calculator, notice there is no cotangent button. All we have is sine, cosine, and tangent. There's this little sine to the -1, cosine to the -1, and tangent to the -1. Those are not the reciprocal functions. We are going to use those in a little bit, but tangent to the negative first is not cotangent. It means something different here. So what is the cotangent of 2? Well, I know cotangent of theta is 1 over tangent of theta. So in my calculator, cotangent of 2 is 1 over tangent of 2. So on my calculator here I'm going to change to radian mode, since notice there's no degree symbol, so that means we're dealing in radians. So I go to mode, go to radian, I hit enter, I quit, and I type in 1 over tangent of 2. So the cotangent of 2 is going to be negative 0.458. So also another thing to notice, I didn't put any units on this 0.391 or this negative 0.458. Why didn't I put any units on that? Well, that's because they represent ratios of sides of triangles. There are no units. It is not the answer is not an angle. The answer is a ratio of sides of triangles. So now I want you to try and evaluate the next two. So the secant of 219 degrees and the cosine of 100 radians. So pause the video, evaluate those, unpause when you're ready to check your answer. Okay, so with secant we run into the same issue we did with cotangent, where secant is not a button on our calculator. But secant is a reciprocal of cosine, and cosine is a button on a calculator. So the secant of 219 degrees is the same as 1 over the cosine of 219 degrees. I can type this into my calculator and I get negative 1.287. The cosine of 100 radians, I just changed my mode back to radians. Here I needed to change my mode to degrees. Change my mode to radians, type in cosine of 100, and I get 0.862. Okay, well what if we want to go the other way? What if we actually want to find the angle? So we want to find theta in degrees and in radians, between 0 and 90 degrees and 0 and pi halves radians. We'll talk about those restrictions in a little bit, giving these trig function values. So if I know the sine of theta is 3/4. Now remember we talked about on previous problems when we were doing right triangle trig, if I know the sine of theta is 3/4, if I just want to find the cosine, the tangent, the secant, the cosecant, and the cotangent of theta, I don't actually need to find theta. But what if I want to find theta? I digress. I don't need to find theta because I could draw a right triangle, and I could solve the right triangle without actually finding theta. What if I want to find theta, though? This is where the inverse button on the calculator, so that was that's where this is going to come into play. So how do I use that? Well, on my calculator, or what is actually going to happen, and we'll talk again more about this a little bit later to learn more about the specific inverse functions, but for now, to find theta, theta equals sine inverse of 3/4. So if I want to find theta in radians, I make my calculator in radians. If I want to find theta in degrees, I put my calculator in degrees. My calculator is currently in radians, so I'm going to do radians first. So I'm going to do second sine of 3/4. And I get 0.848 radians. Now, we don't normally need to label radians because we know that if it doesn't have a degree symbol, then it's radians. But for our practice sake here, I'm going to, just so we don't get confused. Now I'm going to change my mode back to degrees, and I'm going to type in the same thing. A little calculator hint, if you don't know how to do this, you can always recall the last few things you entered into the calculator, so instead of typing in second sine 3/4 again, I can hit second and enter, and it brings up the last entry. And if I kept hitting that, it would keep bringing up previous entries. And now that my calculator's in degrees, I hit enter and I get 48.590 degrees. So now, once we have one of the angles in either radians or degrees, you could also find the other one by just converting that radian measure to degrees or that degree measure to radians. Okay, so I want you to try and find the cosine inverse of 3/5. Find theta when cosine of theta equals 3/5 in both radians and degrees, and find theta when cotangent of theta equals 3 in both radians and degrees. So pause the video, find those, unpause when you're ready to check your work. Alright, so for the first one here, we know theta is the cosine inverse of 3/5. So in degrees, theta should come out to be 53.130 degrees. In radians, theta should come out to be 0.927. For cotangent, well again, cotangent is not a button on our calculator, so how do we deal with that? Well, I know that the cotangent of theta is 1 over the tangent of theta, but I also know in this case the cotangent of theta is 3. So if I look at this equation and I solve it for tangent of theta is 1 over 3. Therefore, theta is the tangent inverse of 1 over 3. In radians, then theta is 0.322. And in degrees, theta is 18.435 degrees. Now notice that all of our answers came out within our restrictions. Part of that was intentional on my part. There are potential problems where that will not happen, and we'll again talk about that more later. But for right now, I want you to think about why are the restrictions necessary when finding the angle. Why do you think they are? There's a lot of reasons. Let's see if you can write down a few. So pause the video, write down any thoughts you have, and unpause and we'll discuss a little bit. So there's two main reasons, and maybe you came up with other things, and that's okay. They're probably correct, or maybe they're not. If you aren't sure, you can ask me tomorrow in class. But one of them is that there's an infinite amount of coterminal angles, remember. So that means that technically there's an infinite amount of theta values where the sine of theta is going to equal 3/4. You can't write down an infinite amount of answers, so you need to restrict them somehow. Actually, there are ways to write down an infinite amount of answers, but we'll get into that later also. Another reason, and the main reason for this specific restriction that we're looking only between 0 and 90 and 0 and pi halves, is because then we're actually finding the reference angle. And it's easier to think in terms of a reference angle because that means we would be able to draw a triangle to represent this scenario. If we have something larger than one of those angles, then we can't draw a right triangle. I should be more specific. Not just any triangle, but a right triangle. So these are two reasons. Alright, next example. So if you have a ramp that's 27 feet in length and it rises to a loading platform that is 5 feet off the ground, I want you to draw a right triangle that represents the problem. I want you to use a trig function to write an equation involving the angle of elevation, and I want you to solve for the angle of elevation. I want you to do all three of those. If you get stuck at any step, unpause and check your work, but try to find all three. So pause the video. Alright, so for the first part here, you should have a picture that looks something like this, basically a right triangle where the hypotenuse is 27 feet, the height is 5 feet, and then a theta or some variable down here to represent the angle of elevation. So if you didn't get that, pause the video again and try to do the rest. If you did, then let's move on. So then a trig function that I could use to involve the angle of elevation would be sine, because sine is opposite over hypotenuse. I could also use any of the other trig functions because I could use the Pythagorean theorem and find the third side of the triangle. But since I don't like to do more work than I need to, I'm going to use sine. So I know sine of theta is 5 over 27. So again here, if you got stuck at this step, pause the video and see if you can solve for theta. If you are checking work, let's move on. So then I solve for theta. Theta equals the sine inverse of 5 over 27, which is 10.672 degrees. Now notice that I didn't specify radians or degrees. So if you found your answer in radians, that's great, that's fine. However, most of the time in application problems like this, degrees are nicer because you can hopefully, you have a better number sense of degrees. You can hopefully visualize what does 10 degrees look like, how big of an angle is that. Whereas if you have something in radians, it's not necessarily as easy to visualize how large or small that is until you become comfortable working in radians, of course. Okay, so from this we just want to understand how to type things into our calculator. Recognize that if we're solving for an angle, we use one of the inverse functions, which is second sine, second cosine, or second tangent. And if we have the angle, then we just type it into the calculator how it is. Sometimes we have to use a reciprocal because secant, cosecant, and cotangent are not on the calculator. Also, whenever you are typing an angle into your calculator with a trig function, or when you are solving for an angle via a trig function, you need to make sure you are in the correct mode. That mode will be determined based on either the units that the angle was given in originally, or the units that the problem tells you to find the angle in for an answer.